Today's video is on kurtosis. So this is from measures of central tendency and distribution from statistics. In my earlier video, I have taught you about skewness, which is the distribution of the data, and in kurtosis, which is used to describe the peakedness of the curve. See here, kurtosis is another parameter which describes the properties or the shapes of the distribution. Generally, normal distribution is symmetrical. It has no skew at all. The skew equals 0. Kurtosis measures the degrees of peakedness and flatness of the distribution. See here, this measures the degrees of peakedness and the flatness of the distribution. It studies the divergence of the given distribution from the normal distribution. And next one, commonly kurtosis is used in statistics, engineering and physical sciences. And coming to this, see here, we have to measure the distribution and the shapes of the distribution using the kurtosis. Kurtosis measures the degree of peakedness here. See here, if the quotient of the kurtosis is greater than 3, then we say that it is leptokurtic. When we say that it is leptokurtic, see here, the peak of the distribution is tall and sharp here. See here, the peak is very tall and sharp here, and the distribution is leptokurtic if the quotient of the kurtosis is greater than 3. And here coming to mesokurtic, here the peak is at a perfect height, not too short, not too tall. The tiles are neither too heavy nor light. The quotient of the kurtosis here is equals 3. And next one coming to platykurtic here. The peak of the distribution is flat here. The distribution is platykurtic if the quotient of the skewness is less than 3. If the quotient of the kurtosis is greater than 3, it is leptokurtic and it is having a highest peak, tall and sharp peak here. If the kurtosis equals 3, then it is mesokurtic. See here, neither too tall nor too flat here. And next one, coming to quotient of kurtosis less than 3, we say that it is platykurtic here. And this is the description of the data. And here the kurtosis is used to describe the peakedness here. Here the peak tells us how tall the distribution is, and it is usually the tallest part of the distribution. And next one, the tail tells us how wide the distribution is and represents the ends of the distribution here. And how we measure this kurtosis, the measures of kurtosis. The measures of kurtosis of the frequency distribution are based upon the fourth moment about the mean of the distribution. Here, beta 2 is equal to mu 4 by mu 2 square here. So this is the fourth moment and this is mu 2 is the second moment. So depending upon the beta 2. So beta 2 here, beta 2 is equal to 3. If beta 2 is equal to 3, the distribution is said to be normal. Neither flat nor peaked here. So it is in middle, that is mesokurtic. And next one coming to beta 2 value. If beta 2 value is greater than 3, then the distribution is said to be more peaked and the curve is leptokurtic. Here, if beta 2 value is greater than 3, then it is called a leptokurtic. And next one, talking about the platykurtic, depending upon the beta 2 value, if it is less than 3, the distribution is said to be flatter than the normal curve and the curve is platykurtic. So here is the distribution here depending upon the beta 2 value. So if beta 2 is equal to 3, it is mesokurtic. So it is in middle. See here, middle mesokurtic. So M for middle and M for mesokurtic. And next one, this is if beta 2 is greater than, if the quotient of the kurtosis is greater than 3, as it is having a longest peak and as it is having a longest peak, the length is very too tall and therefore L leptokurtic. Remember like that as I did so. And next one, as it is very flat, it is platykurtic. See here the three words here, leptokurtic, mesokurtic and platykurtic. As it is having a long tail or a long peak, leptokurtic. As it is in between, in middle, it is mesokurtic. As it is having a very flat peak, it is having a flat peak and beta 2 is less than 3, it is called platykurtic. Likewise, you can remember all these kurtics. And therefore, this is about kurtosis. Kurtosis is nothing but another parameter would describe the properties or the shapes of the distribution. Hope you guys understand. In my tomorrow's video, I'll be posting the problems related to kurtosis, and this is the most important topic. See here, it is very clear through this video. And if you really like, what to do, please raise your thumb, pass it on to your friends, and subscribe to this channel and go to the playlist. And many videos are uploaded for your preparation. It will be damn easy if you follow one after the other. Thank you so much for the support till date. Thank you so much.